Hi class. So this section is going to talk about the theory of the ANOVA. Okay? So here's basically the theory. I have two groups, A and B. And when I have these two groups, so if I'm going to compare the difference between these two groups, I'm looking at a t-test. When I throw in a third group, let's call it C, then now I have to look at the ANOVA, or the analysis of variance. So there are these three groups, okay, A, B, and C. And there are a number of statistics that you can calculate based on these three groups. So clearly, you can see that you can calculate the means, right? And then also, you can also look at the differences between these means, how far away they are. So when you're looking at an ANOVA, one of the first things you have to consider is each of the values in your group, okay, how far they are from the mean of that particular group, okay, and that's your within variance. So if I look at, the differences between, let's just say A was 8, 11, and 5. Let's just say that those were 8. That was 8. So A is 8, 11, and 5. Okay. Then the mean of A would be 19, 24. It would be 8. Okay. So there's one type of variability where I'm trying to look at the difference within A. So it's basically comparing the value 8 to 8, 11 to 8, or 5 to 8. Okay, so that's the within part. Okay, and you do a similar one for B. So let's say B would be 10, 9, and 8. Okay, make it nice and easy for me. And the mean here, of course, is 9. And so the within proportion, excuse me, the within part of B would be comparing 10 to 9, 9 to 9, and 8 to 9. And let's just say C was 7, 8, and 6. Okay. Again, the mean here is 7. And you're comparing 7 minus 7, 8 minus 7, 6 minus 7. So that within variability, I'll call within, you calculate the variable value minus the mean of that group and square it. So you can consider the within in this case and say, okay, I have 9 values, so I'm adding up 9 terms. Right? So the first term is 8 minus 8 squared. Right? 8 minus 8 squared. 11 minus 8 squared. 5 minus 8 squared. 10 minus 9 squared. 9 minus 9 squared. 8 minus 9 squared. 7 minus 7 squared. 8 minus 7 squared. And 6 minus 7 squared. Add all those up and you get a within term. Okay? And this is actually called your sum of squares within. Sum of squares within. Okay? So the sum of squared within term, you have to consider how many values you have in total and how many groups. So in terms of a degree of freedom, we talk degrees of freedom, right? You would have in total values. So in total I have 9 numbers, 8, 11, 5, 10, 9, 8, 7, 8, 6. In total numbers minus the number of groups. Okay? So this is total, and this is your number of groups. Okay? So in this case, the degrees of freedom would be 9 minus 3, which is 6. Okay? So that's one type of variability, the variability within groups. Another type of variability is the variability between groups. Okay? So to do between groups, we look at the difference of the differences between the means. Okay? Let's keep that in mind as I look at the next slide. Okay. So now since we have the within, let's look at what between is. If I took the overall mean of all these values here, okay, this will be considered the grand mean. The grand mean has a symbol x bar bar. Okay? So what is that number? 8 and 11 is 19, and 5 is 24, and 10 is 34. 34 and 17 is 51, and 7 is 58. 58 and 8 is 64. 64 plus 6 is 70, and I can't add clearly because that doesn't look right. 8, 19, 24, 34, 30, 30. Wow. And okay, so now I'm just playing a little dumb again. Try one more time. 24, 34, 43, 51, 58, 64, 66, 72. Okay. So 72 divided by 9 is 8. So our grand total is 8. Okay. If we're looking at each of the groups, how far the group mean is from the overall mean, we're looking at a between groups variability. So I'm going to erase the within part. In this one, well, actually I probably can't erase the between group. This one is going to be your between. Okay? So if I did x bar minus x double bar squared. So if you remember, the first one was a mean of 8. You're looking at 8 minus 8 squared, which is 0, right? Plus, the next group was 9. 9 minus 8 squared, which is 1. And the last one was a mean of 7. So plus 7 minus 8 squared, which is also 1. Okay? So these numbers you need to give to each of the values in your data set. So for example, for each of the 3 values of A, I'm doing 8 minus 8 squared. So I'd have a 3 here. For each of the values of B, I'm doing 9 minus 8 squared. So I'd have a 3 there. And for each value of C, I'm doing 7 minus 8 squared. So I'd have a 3 there. Okay? And so then you just calculate the number. So the first term falls out. The second term, 9 minus 8 is 1. 1 squared, 3. Plus negative 1 squared is 1 times 3. 3 is 6. So your between sum of squares is 6. Okay? Now, the degrees of freedom for your between sum of squares is the number of groups you have minus 1. So in this case, I have 3 groups. 3 minus 1 would be 2. All right. So we have the sum of squared between, and we have within. Okay. Just remember, sum of squared within took each of the values, x minus x bar squared, right? And the sum of squared within, between, took each of the averages for each value, x bar minus x bar bar squared. Okay, so for each case, the degrees of freedom, the first one is n minus k, where k is your number of groups and n is your total number. And for the second one, we have k minus 1. Again, k is your number of groups. Okay. So if I took my sum of squared and divided it by the degree of freedom, we collect what's called your mean squared value. Okay. So your ms within is just ss within over n minus k. And your ms between is just SS between over k minus 1. Notice that you have two different types of variability. You have the variability within the group and the variability between the group. And so the total variability is the sum of those two, which means that the degrees of freedom overall would be the sum of the degrees of freedom. And true enough, n minus k plus k minus 1 gives you n minus 1, which is typical the number of degrees of freedom for a data set. Okay, so now we have a mean squared value within and a mean squared value between. If you took the ratio of those two, particularly the ratio is mean squared between divided by mean squared within, okay? Mean squared between and divided it by mean squared within, you would get an F statistic. Okay? An F statistic is a comparison of variances. So in order to determine what the critical value is for your F statistic, you need to consider both degrees of freedom and your significance level. So this value here is going to be compared to the F statistic with k minus 1 degrees of freedom and n minus k degrees of freedom and whatever your significance level is. Now, if you look in your table in the back of your textbook, we actually do have tables, and probably in another video I'll show you how to read them. But first I just want to plug in the numbers here so you can see that we get what we should in fact get. Okay? So if you remember the sum of squared between, you have A, B, C. Okay? 8 minus 8 was 0. 0 squared is 0. So I have a 0 there. 11 minus 8 squared is 3. 3 squared is 9. Okay. 5 minus 8 squared is negative 3. Negative 3 squared is again 9. Okay, so I have 18 from this part. Now for B, I had 10, 9, and 8, right? So 10 minus the mean of 9 is 1. 1 squared is 1. 9 minus 9, 0. And then 8 minus 9 is negative 1. Square that, I have 1. So I have 2 from B. And then for C, I have 7, 8, and 6. So 7 minus 7 will be 0. 8 minus 7 is 1. And negative 6 minus 7 is negative 1. Once you square it, it becomes 1. So I have 2. Okay. So for my sum of squared between, it's the sum of these three numbers, 18, 2, and 2, which gives you a total of 22. Okay. So on the numerator, I have 22 divided by something. Oh, sorry, that's my within. That's my denominator. So on the denominator, I have 22 divided by, okay, n minus k is the degrees of freedom. N is 9 because I have 9 values. I have 3 groups. 9 minus 3 is 6. So this is 22, 6 is in the denominator. What's in the numerator? Okay. The numerator takes the mean values and subtract it from the overall mean. So if you remember that x1 was 8, x2 is 9, and x3 is 7, and the grand mean was 8, right? Yep, 8. So we'll do the same type of thing here, and I'll just call this a x bar column. Okay, so 8 minus 8 is 0. Square that, you get 0 for the first one. 9 minus 8 is 1. Square that, you still get 1. And 8 minus 8 is 0. And then you square that, you still get 0. You get 1, I'm sorry. So I have 8 minus 8, 9 minus 8, 7 minus 8. So for each case, for each of the three values, I have 0 contribution for x bar 1, 1 contribution for 2, and 1 contribution for 3. And then I add these up. So 0 plus 3 gives me a 6. Right? Does that make sense to you so far? Hope so. So now I have 6 as my sum of squared divided by my total degrees of my between degrees of freedom, which is n minus 1, k minus 1. So I have 3 groups. 3 minus 1 is 2. That gives me 3 up top. Okay. So I'm going to erase this now. Hopefully you guys have had a chance to look at it, because I just want to get some more space here. Let's erase this here, because I just want to simplify my F statistic. Okay. Which I can do relatively easily. So if I look at this F statistic, I have 6 over 2 times 6 over 22. Okay. Alright, I can cancel out a 3. Cancel this out, make that 11, make that a 3. So you got like a 9/11 as a value for your F statistic. And if you plug that into a calculator and simplify it, you get 0.818. So I have an F value of 818. Okay, 818, not 811, 818. I need to compare this number to the value of F, comma, 2, not even comma, F2, comma, degrees of freedom on the bottom one is 6, comma, let's say 0.05. Okay. When you grab your F statistic, you'll find that that number is 5.14. If I were looking at the 0.01 level, that number would have been 10.92. And like I said, I'll show you how to do that in probably another video. But since my F value of 8.818 is less than the F value of 514, I would conclude that there is no difference in the average means of the three groups. Pretty much the same thought process of a hypothesis test. Okay? That's the gist of it. In my next video, we're going to redo the same example, but we're going to, of course, use technology. Okay? See you in a bit.